Hello everybody. Today I have the homework help video for the homework from 3.2.1. So I'm going to be doing most of the problems. The only one I don't go over is number 67 and then part C and B of 69. Everything else I will be going through today in our video. Right now I'm standing right in front of my laptop, so my voice might sound loud. When I move over to the smartboard, it will probably sound a little bit quieter. So I'm going to begin with problem 63. So in 63 in your book, it goes to 5 different terms in this sequence. So we kind of see this picture, right? And we've got in our first one, there's 1 dot. In our second term of the sequence, there's 3 dots. And then in our third one, we can see if we count them up, there's going to be 5. And so what I've included is a table to kind of organize your thoughts. So a good way to start this problem is to start by writing what you do know. So in the first one, we know that we have 1 dot. In the second one, there's going to be a total of 3 dots and 5. Then we'll have 7. And if we continue this pattern, our next one would have 9. So what we're interested in doing is coming up with an equation in order to figure out what the term would be for our 46th term. We can kind of see that no matter what number we plug in, we're always going to get an odd number back out. So we're interested in finding something that's going to generate an odd number. If you look, our pattern is to get from 1 to 3, we had to add 2. To get from 3 to 5, we had to add 2. And then this pattern continues. So when we try and write this function, we're going to write a function t of n. We know that every time we need to add 2 every time. So repeated addition is really just multiplication. And so we're going to take 2 times n. And that 2 just comes from that number I keep going up by every single time. N is how many times I've gone up. Now we're not done yet because we need to figure out what's going to happen when we plug it in. Right now, if we were to plug it in, if my first one is supposed to give me a 1, when I plug it 2 times 1, we have 1 is equal to 2, which doesn't work out for us. So we need to add something else in order to figure out what that value should be. So I'm going to subtract 2 from both sides, and I find out that I need to have x is equal to -1. So let me rewrite that. So we're going to say that what we need is the equation t of n is equal to 2n minus 1. Well, let's try that with another one. This time I'm going to try it with 4, 7. So when I plug 4 in for t, if I do t of 4, I know that I should get 7 for an answer. So I'll do 2 times 4 minus 1, which is equal to 8 minus 1, which gives me 7. So we can see that our function works. So in here I'm just going to write our function rule, which says that 2n minus 1. Another really easy way that a lot of people like is basically what you're doing is you're finding the 0 term. What would it have been if it had been 0 to start out with? If that's the case, your arrows are going in the opposite direction. So every time we move to the right, we add 2, and every time we move to the left, we subtract 2. So we know our 0 term should be -1. That's another way you can find out what your starting value would be. And it then asks us to find out what happens when we have our 46th term. So I'm going to plug that in. We want to find our 46th term. Oops, 46. So we're going to take 2 times 46 minus 1. So if you were to double 46 and take away 1, you would be left with 91. All right. Moving on, we're looking at number 64. So 64 is a word problem that we're going to put into equations. So we know that a piece of metal is at 20 degrees Celsius, and it's going to increase at a rate of 2. So what I'm doing is creating an equation. First, let me think about some of my variables. Well, I'm going to let the temperature in degrees Celsius be what I'm going to call capital T. And then I'm going to let my time in minutes, I'm going to call it 10, because I've already got a T. So that's going to be my time in minutes. And for this first one, we want an equation that's going to model the temperature after so many minutes. So we know that we're going to try and solve for T. We don't know what the temperature is going to be at any given minute. We know that it starts at 20, and it's going to slowly start warming up at a rate of 2 per minute. Using those same variables, I'm going to look at my next one. So then they say there's another piece of pipe. Now this one's cooling off. It says it starts at 240. So again, we're going to solve for what the temperature should be. It starts at 240 and it's going to get colder, so it's going to decrease in temperature by 3 per minute. What we have is two equations we can set equal to one another. What I mean is that I know that 20 plus 2m is equal to T. And the same way, I know that T is equal to 240 minus 3m. So what I really know is that those two things are equal to each other. So from here, I'm going to get my variables to one side first. I'm left with 20 plus 5m equals 240. Subtract away that extra 20. 5m is equal to 220. We'll divide by our 5. And we figure out that it's going to take us 44 minutes for the two pieces of metal to be the same exact temperature. All right. Moving on to 65. It's another one I'm going to do step by step. So it says the price of a movie ticket is $10.25, and it's going to increase by 3% per year. That means every year it's going to go up 3%. It says use that information to complete A through C. So what's the multiplier in this situation? So the multiplier is the thing that it's increasing by. Probably the one step you need a little help with is, if you think about A, so we know it's increasing by 3%, but that's not our multiplier. Actually, what our multiplier is going to be is, it's going to be 10%. So if you were to take 3% of 10.25, you would get a smaller number. We want something that's going to represent it increasing. So we're actually, the ticket price goes up 103% every time. So I take my 10.25 and I multiply it by 103%, which if you write it as a decimal is 1.03. So my multiplier is going to be 1.03. All right. In B, it asks us to write a function that represents the cost of the movie ticket n years from now. So we're creating a function, so f of n. So what will f of n be after so many years? So we want to take our original price, that's our starting value, which we know is 10.25. Then we have our multiplier, so we're going to multiply it. And we're doing repeated multiplication, which just means we're raising it to a power. And so the thing that we repeat every single time is we multiply it by 1.03, and we do that n number of times. So now it wants us to use this equation that we've created in order to figure out what it'll be 10 years from now. So all we have to do is we're really trying to find f of 10. What you're going to get when you plug that into a calculator is a long decimal. So you're going to get about 13.775. This is real world, so we're talking about money, we're talking about cost. So I'm going to round it appropriately. In 10 years, it's going to cost you $13.78 to go to a movie. And that's if it increases at a rate of 3% per year. All right, so that concludes 65. 66 is pretty easy, but you're definitely going to want to double check your work on this one. This is a common mistake people make on the ACT all the time. So if you're looking at taking the ACT, I would definitely pay attention to this problem. What they say, use the meaning of an exponent to rewrite the expression. So probably the wording is confusing. You're like, I don't even know what this question is asking. I wish I could know so I could solve it. They just want you to expand it out. The common mistake people are going to make is they're going to be like, oh, well, that's really just equal to 3y minus 8. What they did there is they forgot that there's going to be some middle stuff in between. So this never works unless y is equal to 0. But we don't know what y is, so we're going to assume that that's not going to work. So what we're going to do is we're just going to expand it. And really what that means is we have y minus 2 times y minus 2 times y minus 2. Please make sure you're expanding it out. That's all they wanted for 66. I'm skipping 67, so we're going to jump right into 68. So in 68, this one should probably be a little bit easier. I believe this is what we touched on Friday last week. So all it is they want you to really see these two equations that I have up here, are they equivalent? Well, one of the ways we'll know they're equivalent is if we get the same value for x. So all we're going to do is let's solve them separately. So the first one I would subtract away 300, subtract away 300, you get 100x is equal to 200, divide by 100, x equals 2. Over here, we subtract away 3, x equals 2. We can see that what the two equations have in common is if that longer one, that 100x plus 300 plus 5 equals 500, all you really did was multiply that one by 100. And so all we're doing is we have that extra step where we have to divide out 100 at the end. So they're the same equation, they have the same result. The only difference is we had to multiply or divide by 100 to get the other. All right, and lastly, we have problem 69. It says to multiply the expression below using geometric rectangles. I'm kind of hoping you're to the point where you can do this without geometric rectangles, but I will show you that method since that's what they asked for. Let me finish filling this in. So if we're using our geometric rectangles, we know that we should have 5m and negative 1, m, and positive 2. So we really have 5m squared, negative m, 10m, and negative 2. So we're going to combine our like terms. We're going to combine our negative n and our 10n. So our final answer would be that this is equal to 5m squared plus 9m minus 2. In part D, it's just a little bit different. We're not dealing with a quadratic, we're dealing with something just a little bit different. Really what it is that we only have one row and 3 columns. So in my one row, I have my 3x. And then in my column, I've got my 2x, my negative 5y, and my 4. And I take and I multiply it through just the same. So this will be 6x squared, negative 15xy. Please make sure you're remembering that x. And then also, we take our 3x times 4, which gives me 12x. There's nothing that can be combined, no like terms here, so it's just going to be equal to 6x squared minus 15xy plus 12x. All right, that concludes the homework help video. If there's still something you're not really clear on, please feel free to stop by during my office hours in the morning or after school, and we can talk about what you're still stuck on. Hopefully these problems weren't too bad, and the homework help video was effective. Hope you guys